Hello, this is Mr. Wynn, and this video is over right triangle trigonometry. It's going to go over the Pythagorean Theorem and the 6 trig functions. So, a right triangle is just a triangle where one of the angles is 90 degrees. The Pythagorean Theorem is a formula that can only be used on right triangles. The formula is a squared plus b squared equals c squared, where a and b are the legs of the right triangle, and c is the hypotenuse, or longest side of the right triangle. The formula is crucial in trigonometry. It can help us do many things, such as finding missing sides. So here's an example picture of a right triangle, the right angle mark, that means 90 degrees. Here's two legs, A and B. Now you can switch the order of that, it doesn't matter. But C is the hypotenuse, it's across from the 90. That's why I drew an arrow, the orange arrow here. Also remember that angles and sides, the opposite of them, are connected or share a relationship. And that is this: the largest angle pairs the largest side, and the smallest angle pairs the smallest side. So for that picture, since 90 degrees is the largest angle, this goes diagonal across. This side right here, C, is the hypotenuse, the long side. Since it's 55 degrees, this is the second largest angle. It pairs with this side right here, going across that purple line, leg A. So leg A is the second longest side, and since 35 degrees is the third largest, leg B, that side that goes with it, is the third longest, or I can say the smallest side. Smallest angle, smallest side. Alright, so this, if triangle ABC is the right triangle with B as the right angle, alright, if AB is 6 and the measure of AC is 10, find the missing side. So you draw a picture, here it is, right triangle with B at the right angle mark. A to B is this, is 6. A to C is this, is 10. First, here's the form, I'm going to label the sides ABC, so I'll call this one A, I'll call this one B, and C must be the hypotenuse, the 10, no matter what. I fill in the formula. So 6 squared plus x squared equals 10 squared. Do the math. 36 plus x squared equals 100. Subtract 36. X squared equals 64. Square root both sides. When you square a number, remember you get plus or minus. But we're talking about geometry. We're talking about a real triangle. Side measurements cannot be negative, so we ignore the negative 8 and just say positive 8. So we know AB equals 8. Here's another one. Triangle LUV is a right triangle where line segment UV is the hypotenuse. If the measure of LV is 4 and UL equals 6, find the missing side. So I draw the picture. Remember, UV is hypotenuse, and then L has to be the other one. So L is actually the vertex here. LV is, right here is 4. UL is 6. Find the missing side, so label A, B, C. There's A, there's B, and there's C. Again, A and B can switch. It does not matter, but C must be the hypotenuse. Fill in the formula, do the math, combine terms, square both sides. Now, at the same time, I'm not going to do the plus or minus. When you square it 52, you have to simplify that radical. So hopefully you know how to do this. You get plus or minus 2 squared root 13. Again, ignore the negatives. So x is 2 squared root 13. So you could have, your answers could have radicals in there. That's normal. Alright, there are two special right triangles that are very common. They have a pattern that you should memorize to avoid doing Pythagorean theorem so many times. The 45, 45, and 90 triangle comes from cutting a square in half. Hopefully I know a square has all 90-degree angles and all sides are the same. So this is 45, 45, 90. This is isosceles. So remember, if you have two equal angles, you have two equal sides. So this side is paired to this one. This angle is paired to this side. Since the angles are the same, the sides are the same. Anyways, we're going to try to find the hypotenuse. So here's the formula. I labeled it A, B, C. Filled it out. My answer for y was 4 square root 2. So notice, the sides are in order of size is 40, 4, 4, and 4 square root 2. So that's the 45-degree angle, that's the 45-degree angle number, and that's the 90-degree measure number. This pattern for all 45, 45, 90 triangles will match. This would be x, x, x squared root 2. So if one of the sides is, say, 10, it'd be 10, 10, 10 square root 2. Now, as you go backwards, what if the hypotenuse is 50? Then you get to go backwards from the hypotenuse to divide by square root 2. So it'd be 50 over root 2, which you have to rationalize the denominator. Alright, 30, 60, 90 triangles come from cutting an equilateral triangle in half. So for equilateral, you know all 60-degree angles, and then all the sides are the same, so all of them are 8. If I cut in half, this is now 4. This angle is now 30 instead of 60. So I label A, B, C. Fill in the formula, do the math. When you square root 48, you have to simplify that into 4 square root 3. But here, notice that the sides in order of size is 4, 4 root 3, 8. So 4 goes with 30 degrees. 4 square root 3 goes with the 60 degrees. And then 8 goes with the hypotenuse. Alright, that pattern holds true for all 30, 60, 90 triangles. This goes to be x, x root 3, 2x. So you go backwards. Say they gave you the hypotenuse as 50. You divide 2 to get x 25 for 30. And then you times out root 3 to get the 60-degree angle side. Or sometimes you have the middle side. Say it's 10. you have to go backwards, divide by root 3 to get the x. Then once you have that number, you times it by 2 to get this. Alright, so now we'll go to trig. Trig is the study of angle and side relationships in a triangle. By noticing specific patterns, we can find missing parts of triangles. This is extremely powerful. It's used literally everywhere: science, engineering, aerodynamics, gaming, architecture, graphic design. And also, because pre-cal is done mostly without a calculator, we'll focus on setup and calculator-ready answer. There are also many things we'll learn soon where we can get the specific answer without a calculator. So hopefully you remember SOHCAHTOA, or sometimes your teacher wrote like SOHCAHTOA like this as the fractions. Alright, that still works 100% of the time. It covers the basics of trigs and helps us realize that the trig functions on an angle is just a ratio of two sides. You've learned 3 of them, but I'll go over all 6 on the next slide. So, when given a right triangle, pick an angle that is not the right angle. Alright, that angle will be our point of reference. Then we'll label the 3 sides of the triangle appropriately as hypotenuse, H, which I might abbreviate, opposite, which I abbreviate O, and A is for adjacent. Alright, so I'm going to pick this angle right here. So opposite would be this. Now, my hypotenuse always crosses the 90. It does not matter which angle you pick, and adjacent is going to be next to the angle. Alright, notice you can pick any angle that's not 90. There are 2 choices. I could have done this bottom angle or this top angle. If I pick this top angle, this is still hypotenuse, so it's across 90, but the opposite and adjacent flip side. So up here, this is now the opposite and this is now the adjacent. So be sure to label your picture carefully from your angle, your point of reference. The 6 trig functions are sine, cosine, tangent, cosecant, secant, and cotangent. Here are the 3 formulas. This is where SOHCAHTOA came from. Sine is equal to the opposite over hypotenuse, cosine is equal to adjacent over hypotenuse, tangent equals opposite over adjacent. Then you have what we call the reciprocals. Cosecant is hypotenuse over opposite. Secant is hypotenuse over adjacent. Cotangent is adjacent over opposite. So notice that sine and cosecant are reciprocals. Cosine, secant are reciprocals. Tangent, cotangent are reciprocals. Reciprocal means flip the fraction. Hopefully you remember perpendicular parallel slopes is opposite reciprocal. Same idea here. Right? And one common misconception is people think they're inverses. They're not inverses. Inverse functions are where you switch x's and y's. Alright, you need to memorize what these functions are, and here's the way to make it easy. I only memorize the original 3, SOHCAHTOA, and then I notice that sine goes with cosecant and not secant. So that means S goes with C, pairs with C. And then if you do the same idea for cosine and secant, you see C goes with S. Alright, so I remember S goes with the C word, C goes with the S word. Alright, the common mistake kids do, they put S with S and C with C. For example, this is wrong, but sine with secant is not the same thing. Those are different letters. Alright, I then developed the formula using the fact of reciprocals. Remember, reciprocal means flip fraction, so here's an example. Say I have cosecant of theta. Theta is just what we call an angle, could be x. That thing is 1 over sine theta. I'm going to replace sine theta with O over h. Now we have a fraction made of fractions. Let me try to do it. There you go. So when dealing with a fraction of fractions, it's called a complex fraction. Make each thing a fraction and separate them and write as a normal division problem. So this is just 1 over 1 divided by O over h. We don't multiply, divide fractions, we multiply the reciprocal. So I change this multiplication. Then top times top, bottom times bottom. Okay, h over O. That's where that formula comes from. So cosecant of theta equals h over O. This applies to all 6 functions, so and it can go both ways. So if you can go reverse, you could also say sine of theta equals 1 over cosecant theta. If you multiply both sides by sine theta, divide by cosecant theta. Alright, so find the 6 trig functions for the 30-degree angle pictured below. This is all they give us. Alright, so here's our plan. We first need to find the other 2 sides. Unfortunately, I can't do Pythagorean Theorem here, but I know it's a 30, 60, 90 triangle because of the 30-degree angle. So we'll use the pattern x, x to 3, 2x. They gave us a 30, so this is the x. So if I double that, that's going to give me my hypotenuse. That's the 2x. Then if I just get x 10 times root 3, I get my 60-degree angle side. After that, I'm going to label sides HAO and fill in the formulas. So I always do hypotenuse first, that's h. Here's A is next to, oh, I have this there. A is next to our angle, reference angle, and then here is O. Then we're going to fill in these formulas. Now make sure you always reduce fractions and rationalize the denominator if needed. So sine of 30, that's O over h. O is 10, h is 20, reduce, you get 1/2. Alright, cosine of 30 is A over h. That's 10 root 3 over 20. Reduce 10 over 20, get 1/2. So 1 root 3 over 2, or just say root 3 over 2. Then tangent 30 is O over A. fill in that's 10 over 10 root 3. That gives us the 10 just cancels to 1, so that's 1 over root 3, but you cannot have a radical on the bottom, so multiply top by root 3 over root 3. Final answer, root 3 over 3. Alright, cosecant is opposite h over o, so now 20 over 10, which is 2. Alright, secant is h over a. Now, I could fill in the formula and reduce, or I'm going to use a trick. Because these are opposites, they're reciprocals, I'm going to use this answer from cosine 30 and just flip it. So I'm going to say that's 2 over root 3. Remember, we had to rationalize the denominator times root 3 over root 3. So the top's going to be 2 root 3, bottom's going to be 3. And cotangent, a over o, but again, I'm going to use the trick. Since I know tangent, I just flip this final answer to get cotangent. Then I'm going to rationalize the denominator times root 3 over root 3. And then I have to reduce 3 over 3 is this root 3. Alright, now you're not going to have a calculator, but if we do, I'm going to show you that these sides do match. So in a calculator, first make sure you're in degrees. So you go to mode, down, 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 degrees. Alright, I'm going to do the first 3. So it's a sine of 30. So when you have sine, cosine, tangent, cotangent, cosecant, secant, it's just a number. So if I do sine of 30 degrees, it's a number we usually don't know it, but this says it should be 1/2. Hope you know 0.5 is 1/2. Alright, let's try cosine 30. Cosine 30, you'll see this infinite answer. It's irrational. So I'm going to try square root 3. Then all divided by 2. Should be the same number. It is 0.866. Then tangent of 30 is this irrational answer. And let's see if square root 3 over 3 is the same number, which it should be. So right now I'm just verifying. I'm showing that those numbers match. Usually we're going to be missing something. Alright, so in this next example, find the 6 trig function ratios for angle theta here. So here's theta. First, we need to find all the sides. We have to do Pythagorean theorem. We have 2 sides out of 3, so I'm going to label A, B, C, fill in the formula, do the math, you get 12. So now we know it's 12. Also, note, if you know your Pythagorean triples, you can avoid doing Pythagorean theorem over and over. Some commons are 3, 4, 5, 5 to 13, 7, 24, 25, 9, 40, 41. So now this is a 5, 12, 13 triangle. Alright, any multiple of these is also triple. So for example, I could do 5, 12, 13 times 2. So it would be 10, 24, 26. Or 3, 4, 5 times 5. So 15, 20, 25 is another common triangle. Anyways, we label HAO. Here's the hypotenuse. Here's the adjacent. Here's the opposite side. Then fill in the formulas. Again, reduce when possible, rationalize when necessary. Alright, these are nice. They do not reduce. I'm going to go down this time. So if I know 12 over 13, I flip it to 13 over 12. Cosine is going to be 5 over 13. Secant is going to be 13 over 5 because I'm just flipping it. Tangent is 12 over 5. Cotangent is 5 over 12. Alright, 2 more slides. So if you know one side and one non-right angle in the right triangle, you can use trig to find all the other angles and sides. Just pick one trig ratio and solve. Here's an example. Find x. X is the missing side, but we have an angle and this. So we're going to use 37 point of reference, label HAO. Here's H, here's A, here's O. Oops. Notice we have something next to A and H. We had to find a trig function that only uses A and H. Our choices are cosine and secant. It's always best to use root 3, so I use cosine. I fill in the formula. Note, again, cosine 37 is just an answer, some number, we don't know what it is, so we leave it like that. I get rid of the fraction, multiply both sides by 52. We can't do anything else, so this is our calculator ready answer. If you have a calculator, you can type it in. So if you have a calculator, you type it in. Notice I'm right, 52 cosine 37 degrees. I get this answer, 41.529. And inches, which is supposed to be smaller than our hypotenuse, that's good. Last example. If you have 2 sides, you can use trig for all the angles. Just pick a ratio and solve. Here's an example when finding an angle. No, you don't use Pythagorean theorem to find the third side, or use trig once you know an angle that isn't 90. So label HAO from our angle x. So there's H, here's A, here's O. Notice there's something next to O and H. O and H are either sine or cosecant. Best to use original, so we're going to use sine. Here's things. Sine of x is 20 over 25. Reduce the fraction. Sine of x is 4 over 5. Now we get x alone. Remove the sine part by using inverses. Remember, composition of 2 functions that are inverse will cancel out and return the input. So sine inverse of sine of x just gives us x. So we're going to sine inverse both sides. This left side is just x. And we can't need to sine inverse 4, so that's our answer. Here it is if you type in the calculator. Just make sure you're in degrees and press second for sine inverse. So second sine inverse of the fraction 4 over 5 gives us our answer, 53.130 degrees. That's it for the video. Hope you enjoyed it. Bye.